Okay, let's dive into this. We use it every single day, right? For work, for fun, to connect with pretty much everyone. But have you ever stopped to think about what the internet actually is? It feels like this invisible, kind of magical cloud floating around us. But the reality? Well, the reality is way more physical and honestly a lot more interesting.
I mean, really think about it for a second. You clicked a button and boom, in less than a second, this explainer starts playing on your screen. But what was the actual journey it took to get from a server somewhere out there to you right now?
That's right. The data for this video didn't just float down from some satellite or drift out of a cloud. It was almost certainly converted into tiny pulses of light and shot through a gigantic undersea network of fiber optic cables. See, the internet isn't up in the sky. For the most part, it's literally at the bottom of the ocean. So that brings us to the first and maybe the most important point we need to get straight. We have to tear down this idea of the cloud. This quote, it's so blunt because it's just true. The cloud is simply someone else's computer. Or, to be more accurate, it's a bunch of massive warehouses full of powerful computers we call data centers. So when you upload to the cloud, you're really just sending your files over a very real, very physical network to be stored on a hard drive sitting in one of those buildings.
And that physical network is this incredible globe-spanning web of over 400 major cables. Some of them stretch for thousands of miles across the Atlantic and Pacific Oceans. And get this, we're not talking about giant tunnels. Many of these cables are no thicker than a regular garden hose. But they are the superhighways carrying almost all of our international data as pulses of light.
Okay, so if the internet is this massive system of physical roads, how does our data actually travel on it? Let's follow a single piece of information and see what its incredible journey actually looks like.
So the moment you click play, your request doesn't just go straight to the source. First, it hops from your device to your router using radio waves. Yep, that's your Wi-Fi. Your router then acts like a translator, turning those radio waves into light pulses and sending them through fiber optic cables to your internet service provider, your ISP. From there, it zips through these huge internet hubs to find the fastest path to the data center where this video is stored. And then all that video data makes the entire trip back to you all in the blink of an eye. It's wild.
Now here's the really clever part. A big file, like a video, isn't sent all in one big chunk. No way. Instead, it gets chopped up into thousands of tiny pieces called packets. Think of it like this. Imagine you have a giant photo you want to mail. Instead of finding a huge box, you cut it up into a bunch of postcard-sized pieces, put an address on each one, and mail them all separately. They might even take different routes to get there, but once they all arrive, your device knows exactly how to put them back together in the right order.
Now, with billions of devices sending trillions of these packets all at once all over the world, how does anything get anywhere? How is it not just total, utter chaos? Well, just like a real highway system, the internet has a very strict set of rules of the road. And these rules didn't just appear overnight. They were built over decades. It all started back in 1969 with something called ARPANET, which was kind of the grandpa of the internet. And you gotta love this. The very first message ever sent was supposed to be login. But the whole system crashed after just 2 letters, LO. Seriously, what a humble and kind of hilarious beginning for the system that basically runs our entire world now.
The technical name for these rules is a protocol, and the knock-knock joke analogy is actually perfect. For a knock-knock joke to work, both people have to know the script, right? They have to follow the rules. It's the exact same thing on the internet. 2 computers can communicate perfectly even if they've never connected before because they both agree to follow the same core set of rules, which is known as TCP/IP. So that IP part in TCP/IP stands for Internet Protocol, and it gives us the IP address. Every single device connected to the internet, your phone, your laptop, the server holding this video, has a unique IP address. It's the digital version of a home mailing address, and it makes sure every single one of those little packets gets delivered to exactly the right place.
But let's be real. Nobody wants to memorize long strings of numbers just to check their email. That's where the DNS, or domain name system, comes in. You can think of it as the internet's giant address book. When you type a simple name like google.com into your browser, the DNS looks it up, finds the matching IP address, and tells your computer where to go. It's this invisible but absolutely critical step that makes the internet usable for all of us.
So we've established the internet is this huge physical network of undersea cables. But that's not the whole story anymore. A whole new frontier is opening up, and it's not on the seabed. It's in the stratosphere.
And this is where we see two totally different approaches to connecting the globe. Undersea cables are fantastic for connecting big, dense cities, shooting light through glass fibers. But what about all the remote and rural places, the hard-to-reach spots? Well, that's where satellite systems like Starlink come in, creating what they call a mega constellation in orbit that beams data down from space, sometimes even using lasers to pass information between satellites.
And the sheer scale of this new approach is just staggering. Right now, there are over 5,000 of these Starlink satellites orbiting the Earth, weaving this new web of connectivity that can cover nearly the entire planet.
But here's the real kicker. What's the ultimate endgame for building this massive, unprecedented satellite network? According to Elon Musk, it's not just about global internet. This whole cosmic ballet is actually a business designed to generate the enormous amount of cash needed for his real ambition, colonizing Mars. The internet from space is funding the journey to space.
So when you pull it all together, what do you get? It's not a cloud. It's a breathtaking physical system. It's an engineering marvel that stretches from the deepest parts of the ocean floor all the way up to the edge of space. And the amazing thing is, it's still a work in progress, constantly being built and rebuilt.
And that leaves us with a final thought. Our reliance on this network is only getting more intense. The demand for more speed, more data, more access everywhere, it's relentless. So the real question for the future isn't if we'll expand it, but how and where. Is the next great leap in connectivity going to be another cable carefully laid on the ocean floor? Or is it going to be a rocket launching the next generation of the internet into the stars?